Okay, starting out with our lecture 24. Okay, we are basically going to be looking at general polynomials, and we've talked about polynomials before, but a general polynomial will be like y equals x to the fourth plus 3x cubed plus 2x squared plus x minus 1. And we are going to be learning based on this function if crosses at x-intercepts or if it touches at x-intercepts. And we're also going to be learning what the end behaviors of this function looks like. So basically our goal with today's lesson is you're going to look at this and say, hey, I know these three are x-intercepts. I know that it crosses I did that wrong. I know that it crosses at these two specific x-intercepts, and I know that it touches at this x-intercept. And then the last thing you're going to know is I know that my finishing behavior is going to be up on both sides of this function. So basically what we're going to do today is you're going to be able to look at a function like this, and you're not going to be able to draw it necessarily exactly accurate, but you're going to be able to make a sketch of what that function should look like. Okay, so that's kind of our goal that we're going to start with. And our main focus at the beginning, we're going to be looking at the degree, which we've talked about the degree before, but we're going to be looking at the degree, and the degree is going to show us what our end behavior of the function should look like. So let's go ahead and get rolling. Okay, so graphing general polynomial functions. First off, the polynomial functions graphs are continuous. Okay, this means that there is no gaps or holes. Okay, basically it's just saying it's some sort of a squiggly line. Makes it a continuous function. It is smooth. There are no corners or cusps as you are working through these. Okay, and then the other thing that's very important is between consecutive x-intercepts, the graph will either be entirely above or entirely below the x-axis. Okay, so basically it has to be either above or below, and that is the fundamental theorem of algebra, I believe, says that in between the x-intercepts it has to be either above or below. Okay, so let's keep moving. General form of a polynomial function. Okay, we've gone over this one before. This was actually one of your test questions. You had to have this memorized. Okay, f of x equals a sub n, x to the n power, plus a sub n minus 1 to the x to the n minus 1 power, plus dot dot dot. It goes all the way down to a sub 1x plus a sub 0. Okay, basically what we need to be reminded about for this is that the exponents in standard form go in descending order. That's what you need to know. Okay, so you start with your biggest exponent and you finish with your smallest exponent. Okay, and then also a reminder, this n here is the degree, which is what we are going to be looking at now. So we have gone over these basic polynomial functions so far. A function with a degree 0. That would be something like y equals 3x to the 0 power. Okay, now if you have x to the 0 power, anything to the 0 power is just 1. So it would be like y equals 3, which is just a horizontal line. So a constant function is just a horizontal line. Okay, something with a degree 1 would be y equals 2x plus 3. So these are linear functions, degree 1. They're going to be lines that look like this. They could be lines that go down like that. Okay, next you have a quadratic. Y equals x squared plus 3. Okay, that has a degree 2. Those are your parabolas. Your parabolas can look like this. Your parabolas can look like this. Okay, and then finally we have a cubic. Y equals x cubed plus 2 degree 3. We know that our parent function for the cubic function looks like this. You can also flip it and make it look like this. We will see, especially through this lesson, that sometimes your cubics will have a little bit more of a hump in between there, but they have those general shapes, okay? So since we're talking about the general forms of a polynomial function, we also need to know what's it going to be when you have a degree 4, a degree 5, a degree 6, a degree 7, and so on. So down below here, we're going to take a look at this, okay? So what I have right here is I have the graph of x squared. Oh, I should probably, let's turn that on, do not disturb. I have an x squared, which is just our normal parabola, and I should have underlined that x squared in red because that would be in red. Your x squared function is in red. You've got an x to the 4th function. X to the 4th is in green. You've got an x to the 6th function in blue. You've got an x to the 8th function in yellow. Now, all of these have a degree of an even variety. All these degrees have a degree of an even variety. Okay, it's 2, 4, 6, and 8. Okay, and what do we notice about this? Well, every single one of these functions have the same U shape. So it doesn't matter if the number is even on the degree, they all have that same parabola U shape. Okay, now there are some differences in there, but that's the most important thing. They all have that same parabola U shape. Okay, all right, let's look at the next one then. In red, I've got my x cubed. We know what that looks like. Then in green, I have my x to the 5th. In blue, I have my x to the 7th. And then in yellow, I have my x to the 9th. What do we notice about all of these here? Well, they all have an odd exponent, okay? And when you have that odd exponent, they all have the same, and I guess we can call that like a snake shape. They all have that same snake shape. So what this tells us is the degree of a function tells us what the shape of that function is going to be. Any of the even ones make that parabola U shape. Any of the odd ones make that kind of snake S shape as we're moving through it. Okay, so what we need to do here now is we need to talk about the power functions and the degrees and what they end up doing. Okay, so your power function that we're going to talk about is f of x equals a x to the n power. So the a and the n are going to provide us with what it's going to look like. So if, whoops, wrong one here. If a is positive, if I have a positive number in front of it, and n is even. If a is positive and n is even, an example of that would be y equals x squared. The n behavior of this function is going to be that U shape. Now notice I left a gap here in between them, and that is important because all that this tells us, it doesn't tell us what happens in between, it tells us what the n behavior is going to be. So again, if a is positive, whoops, see, that's not what I meant to do. If a is positive, this is what I meant to do. If a is positive and n is even, that's the general function's shape. Okay? Next, if a is negative and n is even. So if a is negative and n is even, that would be something like y equals negative x squared. Well, we know that negative just makes that parabola flip, so the n behavior would look like this. Okay? So now I've got a negative, but my n is even. Okay? So it just flips. Okay? Nothing too crazy there. Next, we've got if a is positive n is odd. What is the odd function going to look like? Well, that's that snake shape. So the snake shape would look like this here. And this would be like y equals x cubed. It would be y equals x to the 7th. Okay? So again, a is positive, so we've got a positive number, but now my n is odd. Okay? That's what my shape is going to look like. And then we have one more possible outcome, and that would be if a is negative and n is odd. Okay? Well, we know if there's a negative, that just causes this thing to flip vertically. So your n behavior would look like this. Okay? So gosh dang it. So we're still dealing with n being odd. Okay? But now we are dealing with it being a negative. So it just causes it to flip. Okay? This whole thing here is a test question. So you need to make sure that you have that whole thing memorized there. Okay? That is going to be a test question. Now, one more thing that I want to talk about, and then we will stop this video. I know it's a little bit of a longer one. Okay? But the power function is what tells you what the end behavior is going to be. So this power function here that we're talking about tells which of the 4 end behaviors you use. Okay, now there's 2 different ways that the power function can show up. The first way is that the power function, if everything is multiplied out, the power function is just this first term. So for this one here, this function, your power function is negative 2x cubed. Okay, so then we can look at that. I can see that my exponent is odd, and I can see that my a value in front of it is negative. So therefore, if I wanted to tell you the end behavior of this power function, it would be this example here. That would be my end behavior. Now, you also deal with some where the things are being multiplied together, which makes it a little bit more difficult. If you're trying to find the power function for this, you're just simply going to look for the first term on each of these. So I have a negative 2. I have an x, and that is an x to the first power. And I have an x squared. Okay? So the power function for this one, I have a negative 2 times an x to the first power times an x squared. And if I multiply all those together, that gives me negative 2x cubed. Okay, so those are the 2 ways that you can figure out what a power function is. Okay, so we've done the end behaviors. This next video is going to be working on how do we know what's going on in the middle of it.